Hi, Vanguards. How are you? My name is Jaren, and I am the Director of Public Relations for VITREUS. I'd like to take this opportunity to welcome you to today's Tech Talk. We are grateful you are here and excited for today's broadcast. From VITREUS, I'm joined by our Chief Technology Officer, Tim, and our Director of Education, Drew. Allow me to introduce VITREUS, where Web3 meets AI. We fuse blockchain technology and AI for seamless compliance solutions. Our all-in-one platform offers data storage, management, and interactivity serving real-world businesses. Our mission is to revolutionize the way traditional companies use digital ecosystems within banking, financial services, insurance, and energy sectors across the globe. Today, we are joined by our friend Brad at MainSail. Their expertise is assisting firms with defending their edge workloads against sophisticated cyber attacks and protecting data in all forms, at rest, in transit, and in use. Before I hand it over to the team, if you are new to VITREUS, you can visit our website, vitreus.io, to read our light paper and learn more. We begin stage 5 of our progressive pre-sale this weekend, Saturday, August the 12th. Now I'd like to hand it over to Tim. Tim, take it away.
Well, thank you, Miss Jaren. Well done as usual. I don't think I could have done a better intro myself. So super excited to have Brad on the Tech Talk today. It's a tough one to get a hold of, as he's not only the CTO of MainSail, he's also the founder. So Brad, welcome to the Tech Talk here with VITREUS.
Thank you. Thanks for having me today.
Yeah. So let's see here. Last time you and I saw each other was what, January of 2020 in New York, I think?
In New York, yeah.
Right before it all hit, we were at an AWS training. So we used to work together in a consulting firm. So I've had the pleasure of working alongside and learning from Brad for a couple of years now. So very excited about this conversation. So we're going to build on the last Tech Talk where we discussed, the platforms of Western Digital. And today I'm very excited because MainSail is about a couple of years ahead of us as far as like the technology that they're developing and the partnerships that they had. And I'll let Brad really get into that, but I'm really excited about, where they've come from, their roots in the federal DoD space, and, kind of what we're going to be able to do from a full tech stack perspective in primarily starting in the energy space, but others in general. So Brad, why don't you tell us a little bit about yourself, your background, and then I would love to get into, how you got into MainSail and what MainSail does.
Sure. A little bit about me. So my background is I'm former Army. I was a radar technician for several years. And when I got out, continued into the tech sector. I was very fortunate at an early age or very early on to come into federal contracting, where I did a lot of, I was in research and development types of roles, doing offensive and defensive cyber, working with a lot of Army customers. From there, I ended up in a couple other jobs, cyber related, but then that led me to MITRE, which is what's called an FFRDC, federally funded research and development. We're basically a big think tank for the government, and again, doing a lot of at that time cloud. So that was brand new. So I did that for a while, and then I finally got a chance to actually work more on the commercial sector, where I was at Red Hat as a solutions architect, and this is right around the time when containers were coming out. So it's like around 2013. So trying to explain to the C-suite executives what a container is. Have a lot of experience explaining very abstract concepts to decision makers. But all of that, using a lot of that, my background with cyber and whatnot, I was in the public sector. So a lot of the things we did was not only take a lot of these emerging technologies and bring them into the government, but also, ensure that they were safe to bring in. So did a lot of, working with security hardening and security teams at Red Hat, did a lot of security evangelism and talking to folks really about Red Hat and how to secure their infrastructure.
Yeah, that's impressive. I mean, not only are you coming from, one of the more heavily regulated sectors in the United States, but you have a deep software development background with Red Hat. So really, when you thought about MainSail, right, you pretty much combine those experiences into an idea, right? And so you create, what is MainSail really providing the DoD at this point?
Yeah, I mean, it was unique to say the least, right? To really be fortunate enough to be in a situation to where you actually are, in a situation where you can come across these advanced technologies, come up with the crazy idea of commercializing them, finding another co-founder that was equally as crazy. And here we are 2 years later, really bringing forth our product. And it's been a wild ride so far. But a lot of the things that we're doing is taking really this DoD based technology and now bringing it over into the commercial sector. So, when you start talking about, having really the deep, credentials and what's the word I'm looking for? Proven technologies on the DoD side and then bring them into the commercial space. It's kind of an honor to really be entrusted with, working with the technology as advanced as this.
No, it's well said. And here's what I'm really excited about. So you and I reconnected when I started here back in February. And when I first got a hold of your technology, I thought I had misread what you guys had built because I didn't know it existed, right? So for the audience, Brad is he's invented what's called a Type 0 hypervisor. It's its simplest form, and what that is it's more advanced and it's more secure than any other technology that can do what's called virtualization, where you take like a server and you put other operating systems like Windows and Linux inside of it, and you consolidate it on one piece of hardware. Well, what makes this really extraordinary from my perspective is he developed it alongside of Red Hat and Intel, and it's made very specifically for a true zero trust, low level architecture, and that's really crucial for us on our technology stack because as we develop our blockchain and our AI, and we want to put this inside of a very secure environment, especially in critical infrastructure and energy, that makes it very advantageous for us. So, Brad, why don't you kind of take us through how did you come up with, like you said, idea? How do you come up with a Type 0 hypervisor that not even Microsoft or VMware or IBM are chasing down? This is something that honestly, when I looked it up, there was a research article from I forget what academia it came from, but it said a Type 0 hypervisor would be this. And you're like, oh yeah, we have it. I'm like, okay, well, tell me more about it.
Yeah. So, I mean, hypervisors, when you hear about them, like now in this current day, you're kind of like, that's why were you talking about kind of a legacy technology? Like everyone's going to containers and WASM and, all of these really high speed new cool things. But at the end of the day, this was really invented for a specific reason. Because a lot of the times when you really start talking about the really advanced threat actors that are out there, they're no longer just going at the application layer to try and exploit things. They're moving further down the stack. They're moving into, the BIOS, the firmware, and now even hardware level exploits, right? You've heard of these things, 2018 Spectre meltdown.
The Spectre meltdown, absolutely.
Yeah. This is one of the reasons that, you actually have to go down into the hardware level to be able to mitigate some of these vulnerabilities. And this is what, our team is, very advanced, able to, work with Intel, Red Hat to be able to, create this low level new hypervisor that actually is able to do this hardware based isolation, right? So if you look at anything else on the market, it's all done in software, right? And if you're talking about these advanced threats that are going down and just really circumventing a lot of those software based controls, you're leaving yourself exposed. And that's why we've, gone all the way down. In fact, our tagline is trust starts at the silicon. And that's where we went to really build the foundation of trust so that you can build, secure systems on top.
So let's apply that to us. Use the word WASM, right? So WASM is how you can basically publish an application. So let's talk about our blockchain. if we wouldn't have this technology in our infrastructure stack, we would be, even though our blockchain is extremely secure and we've got, NAC and cyber ID and all these wonderful aspects within our software, there's still the hardware layer, right? And so explain why even an immutable or a very naturally secure technology like what we're building would still be potentially at risk within the hardware stack. Because you mentioned high level, right? So the applications, which is where a lot of these companies play. And this is where you're revolutionizing zero trust from literally the layer 0 up.
Right. So the way we look at everything, and previously DoD and even now in the commercial world, is the concept called defense in depth. Right. You want to make sure that at every layer you're taking as many steps as possible to secure your assets. While blockchain and the crypto and all of those are happening fundamentally at kind of an application layer, there still can be other things that may not affect the chain, but might be able to have second and third order effects to your system, right? So this is where maybe the chain itself is fine, but if you're talking about third-party transactions and other things that could be affected, that would be within what we call the defense in depth. And you want to make sure that if you're running any of these other types of services, that those are also secure. And that's one of the things that we're also bringing, because this is also, edge computing, where, you're doing a lot of this outside of the public cloud. So you might not have all of the physical controls all the time. And that's where, for us, we're able to encrypt and protect all the data. So if it's at rest, in transit, or in use, it wouldn't matter if someone actually got physical access to a server. They would, everything would still be encrypted, and then you'd also have all the securities that are built into your blockchain. So again, those are the defense in depth protections that we're bringing to the table, and a lot of this is just kind of on by default with our product.
Right. And so what you said something very important. So even if somebody was able to get physical access to a box, right? Your technology from a physical access, from a physical perspective, completely not only protects it, but mitigates any realistic probability of somebody getting into that system. And the reason why that's really important to us is when you're putting our technology, a distributed infrastructure like what VITREUS is, at the edge, sometimes you have to put it in very unsecure places or rugged in the field, which is, why we're working with Western Digital. And we touched on that on the last Tech Talk a lot, about their platforms of vision and how they're used in their innovations, right? But this gives me a huge advantage, because not only am I able to put these very robust, high speed appliances with my technology on it, but now I can put it in these esoteric places or these edge places. And even if a box is compromised, I shut it off and the box is essentially worthless. Is that a fair statement?
Yeah, no, I mean, the Western Digital servers are fantastic, because all of the hardening that they've done to those boxes makes them, first of all, if I'm looking at that box versus something else, I'm probably going to go to the lower hanging fruit than that one. Okay.
Yeah.
That one is, just from a physical aspect, is incredibly hard to get into with all the protections on it. And then when you layer on, the software that we're bringing to start, to securely encrypt everything, where the customer ends up owning those encryption keys, it helps even against, say, like an insider threat. Say someone had a weak password, or they're able to guess the password to an admin console, or, you literally had a legit insider threat. With our technology, since the platform owner has the keys, they're actually able to sign that workload. And it's basically like locking it down cryptographically, and no one can do anything to that workload, right? So you can't remap drives or change boot orders or anything else, which is kind of perfect when you're talking about, I want to put something out to go and work and not have to worry about someone, coming in and changing or, subverting any of those controls. So as far as we know, it's one of the most locked down and kind of cutting edge things you can do to physically protect servers at this point.
Absolutely. So let's talk about, it's great to have protection, and feature and functionality is also really important. I think another thing that I was extremely impressed with when I first saw MetalVisor, which is your Type 0 hypervisor that MainSail has created, was also the performance that you get out of this technology. And, for us, we've been talking to various institutions that speed matters, sub-millisecond speed in some cases. So talk about how you also differentiate from a traditional Type 1 hypervisor like, I don't know, VMware, or even Red Hat's KVM or Hyper-V, Microsoft's Hyper-V.
So I'll start with kind of an admin story that I'm sure might hit home for a couple people is, if you've ever been working on a virtualized system, VMware, those kinds of things, you're going to definitely notice when someone's doing a database backup, that they're deploying a whole new infrastructure right next to you. That's what's called a noisy neighbor. Because basically what happens is inside of traditional virtualization, you have an orchestrator trying to share those resources between people. And sometimes people have a little bit more, I would say more quota, or, a little bit, they can, gain more resources probably than they should. And that's, that'll affect your quality of service, right? So think about if I'm trading, right? Like you bring up sub milliseconds, we're talking about, I'm doing transactions and trading. Now, somebody starts stealing my clock cycles and affecting my workload, you're going to notice it. And that's why a lot of those applications are done on bare metal machines, because they cannot stand any of that interference, basically. So, but you're giving up the benefits of virtualization. Like virtualization is great because you can just deploy an operating system in seconds, right? And backups and all these other.
And high resiliency, high availability, just so many advantages to virtualization. Couldn't agree more.
So, but if you could take away and those noisy neighbors and guarantee basically bare metal performance and still get all the benefits of virtualization, well, that's really what our product is bringing to the market, right? So we're able to guarantee quality of service, especially when we're talking about the edge. I mean, the other big portion of the things that we're doing is a lot of those edge workloads. So not only the AI ML, but other latency sensitive workloads like 5G, right? Which is also kind of becoming one of those things where if I can have my own network and have my own speed and quality of service, those can be really desirable, I think, in certain situations as well.
Basically, what you just said very eloquently is, not only do I have the cybersecurity risk mitigation aspects, but I'm not sacrificing performance or any of the other benefits that come from virtualization, like advanced backups, high availability, failover, time to speed provisioning, where if there is something or if we want to push out an update, we still have all of those benefits where we're not tied directly to bare metal hardware and constantly reinstalling operating systems.
100%.
I guess.
Yeah, we working with Red Hat, we worked with their business units, right, to basically become a certified product and work with RHEL and a lot of their products. And through that, we've also worked on simplifying deployment, simplifying the whole cryptography and all of these types of things, but also automation, right? Like I'm a big fan of Ansible, as well as Swarm and these other modern tooling, because the last thing we would want to do is have people do things by hand, right? And that doesn't really work when you want to scale. So, that's why we've been working on Ansible modules and those kinds of things for deployment.
And so we talked about, we met this morning about what we call our Vanguardian OS, right? And you gave us some very strong recommendations. And let's talk about the Red Hat stack, because we are a Red Hat partner as well. We're following the same wonderful programs that you were able to do a couple of years ago, and building our technology alongside Red Hat, which is one of our primary partners, right? And so when we talk about our vNodes and the underlying infrastructure, talk about Red Hat's Ansible and some of the things that we talked about with our Vanguardian OS this morning, and even on the enterprise side with Western Digital, what we would be doing with MetalVisor, I think it would be really cool to hear from your background what our vNode appliances would be on the back end side. I think people would find that pretty interesting.
Yeah, no. So there's been, I would say, some interesting evolutions in operating systems. Most people think of them as, you would just install an operating system and, you're logging into it and you're making changes and updating packages and all of these types of things. Well, that was a way that we've done it for a long time, but, now we're really using more of DevOps processes, right? So we want to basically write code once and then have some kind of automation push that out. So I can, if I got to configure, 10 machines or 10,000, it's all going to be done the same way. So this is where, we're looking at, using things like Ansible automation to really be able to reach out and configure, multiple nodes. But I'd say the other real big innovation that we've seen on the operating system side is this concept of what they're calling immutable operating systems. What this is it's essentially it's a read-only operating system that you would pre-configure. In fact, Red Hat has a really interesting API where you can basically make an API call and say, I want an operating system built with these packages and these configurations, and it basically spits you out an ISO that you can then install, and that becomes read-only. So I'm not if I need to make a configuration change, what I'm doing is I'm going to do what we're calling atomic updates. So the cool thing about this, and I was explaining this morning, is some of the ways that the file system works is you have an active and passive partition where, one is your active operating system, and the other side is waiting for the new OS update. So when that comes, you basically do a one-to-one cutover, and it's atomic, and basically that succeeds. Or if it fails, you just roll back. But this is a really interesting way of just doing updates, because I know there's probably some sysadmins that are out there that are, very familiar with, I'm doing my Yum or DNF updates, and they're downloading forever because, it's much easier sometimes to download a single file than, 6,000 RPMs, right? So this is another way of just increasing really the stability of being able to, secure and update, hundreds or thousands of machines.
Absolutely. And in my mind, we have a really fun journey ahead of us here at VITREUS, because we're just getting started. We have so many things that we're going to be developing and pushing out. And so, the vNodes are really important to our community. It's where they're going to be, staking and, using their tokens and whatnot. So these types of strategies are really critical for us to be able to responsibly add features, maintain security, and make sure that we do not disrupt the stability of a vNode or a user who is staking. And Drew and Jaron, maybe you guys could touch on, those types of elements and the thought process of what we're putting together, because the last thing that we want is to disrupt somebody's business or what they're doing on their home hobbies, right?
So specifically talking about our vNodes and how secure we're trying to make them, right? Some of the things about updating were what I wanted to ask about. So our vNodes, you can't plug any device into them. You can't access it. There's no GUI, no visual thing. So with MainSail, they can update that OS without any disruption to the device, right? So what you're saying is if it fails, no harm, no foul, it's going to keep trucking. Once it's successful, it's like, okay, now I'm on the new version, and then the old version just goes away without missing a beat.
Right.
That's really important, especially when we're talking about validating transactions on the blockchain, because we want as many nodes working at the same time. We want that speed. So that's super important. When you think about pushing updates in the traditional business sense, we think, Tuesday at 2 a.m., right? I need to take the servers down when nobody's using it. Right. But on the blockchain, it's 24/7, 365. There is no opportune time to take the system down. So can you talk more about how you guys came up with that strategy, or how that is executed in that regard as far as updates?
Yeah, so this is something Brad and I have been talking about since probably February. and really we're talking about two different sides here. So on the energy sector vNodes, right, where we would be putting that with on the Western Digital hardware, that would be the Metalvisor hypervisor with Red Hat's backend technology. What Brad is describing is the Vanguardian OS that would go on
that was going to be my question. It was, okay, y'all were talking about the immutable operating systems. Is that what our Vanguardian OS is? I was trying to make that connection for the community listening.
Right. Yes, it is. And you don't need something as robust as Metalvisor on, our staking vNodes, right? But what you do need is what Brad described, the ability to push updates, whether it's a security update, a feature push, or a new product, right?
Right.
And you don't want to interrupt the blockchain transaction itself, or just the general reputational and the algorithms that Taylor has put together to ensure that that site and power plant stays up, right? We don't want downtime. We want security. We want uptime. So yeah, that's a really important strategy, and it's very complicated. And this is something that I've been learning from, honestly, Brad. I mean, Brad, I don't want to just speak for you, but you have given us a lot of guidance here, and a lot of our DevOps strategies have come from your experience and what you've built over the last 2 years as well.
Yeah, a lot of it is also, kind of, being around the DoD. They're looking at implementing, DevSecOps strategies, and especially on the Army side, pushing out, one of the other things that we work with are, cyber kits and these types of things, right? So there's a lot of strategies that we're aware of, and also they have a lot of benefits on the civilian side of things, right? Not to mention, there's if you're able to pass some of these regulations and security and compliance checklists that are on the DoD side, it is going to make your life way easier when you get out and start looking at any kind of PCI, SOX, HIPAA, any of those types of civilian regulations.
Absolutely, and we're looking to be that compliance assurance and efficiency for regulatory agencies and whatnot. So it's a perfect marriage and going into market. And what I'm really excited about is these aren't just things that we've thought about ahead of time. These are things that we're doing now. These are in consideration. So when we go into mainnet testing on November 30th, well, we've already thought of all of these things, and it makes the development of the next round of features and products easier, because the baseline is there and we can test against it, and just make sure that we continue to innovate. We do it securely, we do it responsibly, and we build out the ecosystem in a way that is beneficial for everyone, with uptime, cybersecurity, and different technologies. And that is something that I'm very excited about. So let's move on to kind of what we're doing with the energy sector. So critical infrastructure going to go through some major changes, right, Brad? Your military background and your DoD background is going to very much, you're already having conversations on your own.
Oh, yeah.
I would like you to start with a general question. What are you seeing in the energy space from just the MainSail perspective and the zero trust elements, especially with we've seen some folks have had some pretty serious, breaches and whatnot?
Yeah, it's gonna, I think every industry is, has the, threat actors that are always, looking, trying to get in what we call an advanced persistent threat, because they're always there. They're waiting, they're targeted and looking at, one company, one section of the network, and they're just waiting really for someone not to patch in time, for someone to make a configuration mistake. And you'll see
one Azure token. I'm sure that's too soon, but
that's the name names, right?
The name names.
Yeah. But it's that, when you know that there are those threats out there, and when you have downtime from a ransomware attack or something worse, right, that they can do, you'd want to make sure that you're doing all you can from an infrastructure perspective to really stop those types of attacks. And our technology is something, we're in conversations with people to, look at taking some of their, legacy investments, right? A lot of times you're not going to rewrite a lot of these things because they work and they're just super expensive to do something like that. So that's really almost totally off the table, just about every conversation. But if you can re-platform, right, just by take almost the exact same workload you have and move it over to a secure platform that can basically eliminate several classes of security vulnerabilities, or at least help to mitigate, right? This is something that, we're having a lot of success with talking with people, because it becomes a, hey, don't rip and replace if you can just move, a platform.
And that's
digital is I think a prime example of someone that's been working in that space. When we start talking about how far servers have, on-prem servers have come and what you get compared to, if you were to do something in the cloud, it's really a night and day difference. I mean, with the amount of storage and compute you can get on a few servers that, make replatforming and moving things, almost a no-brainer, especially when you start talking about cost compared to.
And that's another aspect of what we've been talking about together is we don't want this technology to not be able to be adopted because it takes these very large migration strategies or replatform strategies, right? Both organizations, right, MainSail and VITREUS and Western Digital and Red Hat, were able to take our combined and separate technologies, because I love the fact that you guys can also strengthen an energy company's security posture by, hey, instead of using this Microsoft or VMware thing, put it over here and boom, you are in a completely different security posture now. We can do it at the same time where we are adding our value around risk in cybersecurity, mitigation, tokenized training, trading, things like that. But, these sectors, especially, banking and energy, they're not going to go to the cloud as quickly as everybody thinks they will, because they would have already done it. It's either too complicated, too expensive, or quite frankly, it's just not, the benefit just isn't there.
Totally agree. I know we've both seen the commercial side of that, and it is a lot of work to move to a cloud and re-architect everything, and then at the same time you're also seeing a big trend of kind of on-prem repatriation due to rising costs, right? So. This is where I think, in the future, you're going to see, we've always seen that there's going to be what we call like cloud right, where some things definitely make sense. You don't know what the predictability or the viability of certain things are going to be. So like startups definitely want to go to the cloud, but if you have a long running steady state application, you might want to look at, something on-prem, especially when we look at like oil and gas. A lot of these cloud, when you're out drilling somewhere, and a lot of the data that they're actually collecting, I mean, is almost, that's their data is gold, right?
It's at the edge. It's all at the edge.
And I still, I kind of go back to that physical attacks I was talking about in the beginning. It's super simple to do. Literally pulling memory from one machine, throwing it in another. And when we start talking about terabytes of memory data, that's all the attackers at that point, right? So that's another thing we're bringing to the table, securing those systems so that you can say, all right, I can actually trust something, push it out on the edge, and continue my operations, not have to worry about the backhaul links to the cloud. When I can literally do my processing locally. If I need to use the cloud for some type of backup or those types of things, those
or a blockchain. Who knows? Maybe you could find a blockchain.
Exactly.
I know someone who has one of those.
Right. Yeah. Jaron would like all of your rugged cases to be VITREUS purple, please.
Yes, make it happen. Thank you.
Will do.
So let's talk about ransomware, because that is, I think, one of the more common attack patterns that we see, right? And so on our side, ransomware would be a very difficult thing to do inside of the chain. But, we're going to have, to your point, the attack surface is outside of the chain, right? So what do you do when you have a third-party integration or a system where somebody's going to come in and then you're locked out of that completely? Let's talk about, explain what you think, in your definition of ransomware is for the community. And let's just get into how we full stack mitigation strategy in energy that our two companies combined are providing.
Right. So, the way I think about just all malware and really security, and it's really kind of a binary type of thing, right? You have a vulnerability that exists in some type of software or hardware, and then you have an exploit, right? That exploit is able to then, take advantage of that vulnerability. And honestly, after that happens, whether it's ransomware or, anything else that they do, identity theft or, spying or any of these types of things that happen, to me, it's like, well, those are always going to be the impact of, not being able to secure that vulnerability. So for us, what we're trying to do is really stop vulnerabilities, really, even if there is no software mitigation available, right? These are things called 0 days, right? So say tomorrow, there's a Linux kernel bug that comes out and, we're trying to patch and we're trying to get out to some of the systems that might not have internet connection, right? So what we want to do is ensure that, our platform is, from the silicon protecting and hardware isolating, right? So literally if one machine gets compromised, we're making sure that, we're stopping any kind of lateral movement, right? They're moving around. But the other thing is we actually have another thing on our system that we call our active response capability. That is essentially, it's kind of a low level thing, but we're looking and monitoring the workloads for those signs of 0 days, buffer overflows, these kind of stack based attacks that are, end up being pretty vicious and, usually resulting in some kind of ransomware. So our system's able to see these types of things and basically stop it ahead of time.
You have time to breach analytics built into your hypervisor.
Correct.
We could pull telemetry data from and then isolate that through some of the control patterns that we talked about with our DevOps, our SecOps, and not only isolate it, stop it from proliferating bilaterally, but then patch it. And I think that is a really big advantage to this solution, because it's a lot of times when you look at a company and they've had a breach, time to breach analytics is basically the time that a company discovers their breach or their vulnerability, right? And when it actually happened, right? We've seen companies go months, right?
Yeah.
I should have patched that back in February and it's August. Well, sure. But that's actually, these are benefits that we're going to be able to provide companies as well as they adopt these platforms and enrich their ability to have more interactivity into cybersecurity mitigation frameworks and showing things like SOC 2, ISO 20001, any NIST framework, right? I was very impressed by that feature that you guys kind of baked in there. It was really cool.
Yeah, it's, and it's also something that, has been tested, right? So, we've had some, very smart people bang on this system. We're able to see that at such a low level, we can take action based on policy, right? So if you have a policy that says, it's fine, let these things continue, we'll just alert on it, then that's fine. That's what your policy is. But think about, like, if this is a system that is literally storing all the mining data or radar and those kinds of things from oil and gas. The last thing you would want, even if you do have a vulnerability, is a system to stay up while it has these vulnerabilities.
Yeah.
So that's why, according to policy, we can say, all right, the ARC, the active response, can take an action, right, to stop that.
So to simplify this, you're saying, like, if one part of our system or like one node operator, either their node gets compromised or like they don't do the update, if something were to get in, you could shut it down from affecting the whole system?
Yeah, I think of it almost like an autonomous robot that's constantly looking over the platform, right? And when it sees something like someone's launching some exploits at your workload, depending on what the policy is, we can essentially halt that machine, or we can take other actions depending on whatever the policy is. And that's
Awesome.
one of these things. It's like, hey, if I can't be there in person to, have my SOC team like looking at and monitoring, this is, just a great automated way of protecting those workloads when they're going to be out at the edge.
And imagine taking that data, Jaron, inside of ComplyQ and making that relevant from a cybersecurity perspective, where they're going to be able to see that, interact with a query against it. It's a beautiful marriage of data as well. This is where we've been talking a lot about the software and the appliances, but Brad and I have also been speaking about the rich analytics and what we can feed into our front side ComplyQ product in different facets as well. Now, those are future conversations, but certainly advantageous as we get down to these roadmaps and we get these things a little bit more further down the pipe, closer.
Well, I'll tell you, I'm impressed he was talking about oil and gas, because my mother is actually a director and a VP in acquisitions in oil and gas, and for acquiring land assets. And I know for a fact that industry is cutthroat. So, I mean, if it works there, that's pretty impressive.
Yeah, I have family in Dallas, so yeah, very aware.
Yeah.
Oh yeah, gotta go after that. But yeah, so we're bringing up. Thank you for that, Jaron, because we bring up oil and gas because those are the more rugged, very difficult scenarios, and we're solving it there. And as you get closer into traditional data centers and whatnot, it just gets even more fun. So, Brad, any topic that you wanted to bring up that I didn't cover that you want to bring up before we go to questions?
Maybe I can prod you with one. Can you talk about TPMs and how you guys integrate with that?
Yeah, so TPMs are really interesting, right? So we actually don't end up using TPMs, because if you actually look at the way from boot, right, you have the CPU power on, and then you have several other operations, and then you finally, you're loading drivers and whatnot, then you're getting to the TPM. And then
you want to explain what a TPM is, Brad?
I forget what the actual acronym is,
Trusted
but it
Platform
literally
Module.
is just a device to generate.
What's that, Drew?
Trusted Platform Module.
Trusted Platform Module, right? And basically, its job is really to generate randomness for keys and cryptography and those types of things. There have been exploits out there that basically have subverted the TPM, right? And this is the level that we are going to for this. When you said start at the silicon, we are actually able to do a lot of that key generation in the chip itself and get very high entropy.
So that, when you mean from the silicon, you mean power on, here we go, here's MainSail first. Exactly. That's incrable.
Yeah.
That's pretty impressive.
Drew, this is your world. What is it? You don't boot up into the BIOS, Brad. What is the silicon that you're booting into? I forget the name of it.
So we're still a UEFI based system, but like if you can really think about us, the way that we're starting very, very low, you'd say we're a type 0 hypervisor, but we're also doing a lot of these security functions in firmware. So that's the other kind of thing, is we could almost call us a firmware based hypervisor. So a lot of this, we're setting up hardware partitions and the security of the keys and the signing of domains and all of these types of things. It's incredibly low level and complex stuff, and I think we've tried to bring it up to a level where people can understand. And I think when you start looking at honestly some of the performance demos that we can give, or some of the things that we can do around security with some of the pen testing and stuff we've had done, it's really a pretty amazing platform.
Yeah. So when you boot into UEFI mode, right, you're taking Red Hat Enterprise Linux, and basically you're installing on the firmware and the different pieces, which is way more secure than a traditional BIOS. And go ahead.
And it's so we're trying to not break anybody's current workflows either, right? That's why we're trying to integrate with as much open source tooling and APIs as possible. Like we work with libvirt and to launch virtual machines. There's things we're adding to it, right? But again, we're trying to make sure that the performance and security doesn't come at a cost of usability, right? And that's always what ends up happening with
and libvirt is the command you run to get KVM going inside of Linux. So it's a very common virtualization library that a lot of folks use. So a lot of support around that.
Yeah.
So is MainSail's solution limited to like LGA or AM4 platforms, or is it just, it doesn't matter?
So since we did a lot of our integration with Intel currently today, that we're mainly on Intel chips, right? Like the second, third generation Xenons, Ice Lakes, those types of chips, right? Really the server grade ones that can really host virtualization. That being said, the Intel does have smaller form factors like Ice Lake D and whatnot that are getting pretty small, more ruggedized. And those are, we're working with those, and we also have a roadmap too on other things that we're potentially going to be working with, and that'd be a fun thing to come back and share at some point.
Oh yeah, and in Intel, what you've done is those are very specific Intel features, right, and firmware, the UEFI, but we can still use NVIDIA cards and Mellanox and different things inside of the motherboard, right?
Yeah, so we work with being able to basically sign, cryptographically sign every PCI device, right, and be able to lock it down even from a hardware perspective. So this is where I was kind of getting into, like, not only are we locking down like an admin interface with someone trying to do something from like a console to remap drives, that kind of thing. Also on the hardware side, right, we'll know when things happen, when devices are changed and that kind of stuff, because it's all just it's cryptographically signed.
Yeah. That's so cool.
When you were talking about virtualization and keeping things siloed, so let's say I've got a VM, 128 gigs of RAM that I'm sharing against 8 or whatever, and I got a memory link in one due to a vulnerability. You're saying that even if a bad actor can get in my VM and manipulate that particular piece of hardware, it can't get outside of that silo and affect other VMs?
Right, because the way, if you look at like a virtual machine today, it's all done in software, and you have kind of like these imaginary partitions between it. It's all software enforced. Since we're in the firmware where we set up our partitioning, right, you can think of it as a hardware enforced partition, so that even if the software is acting crazy or compromised or trying to memory leak or those kinds of things, it's going to have it's not going to matter, because at the lower level, we're using these, CPU and, all these low level features to basically, stop those types of issues from happening.
That's incredible.
It's full isolation because everything is cryptic.
If I had a whiteboard, it'd be fun to get out and start doing the marker board.
Don't get us started on whiteboards, right?
I was gonna say.
That's what I do. With former Red Hat, just give me a marker, and
our head of products, Taylor, is well known for his whiteboards. He used to have them like lined up around his office. Now he does it all on the computer.
Accurate.
Look back like this and
accurate.
We love Taylor. Those whiteboards come in handy.
Yep.
Yeah. Great question, Drew. Anything else, Brad, before we open it up to any community questions?
No, I just say that our website's at MainSailIndustries.com. If anyone wants to go there and just kind of see kind of visually some of the things, there's some good blog postings that talk about the security more in depth, some of the stuff we're doing with Red Hat and reference architectures and those kinds of things.
Great plug on the reference architecture with Red Hat. So that's a future state for us, right? Mm-hmm. You guys are a bit ahead of us, but I would love to show that out there, because it's not only was it very well written, but you guys are out there co-selling with Red Hat, pushing that out there. You've already gone through the process to get that into their marketplace. So congrats on that. That was a big win for you guys. That was a lot of work.
Yeah, absolutely.
Cool. Ms. Jaren, any questions from the community?
We have got a few.
Okay.
Let me go scroll up here. Okay.
Sure.
So this first question will be for Brad. It says, does MainSail try to make predictions or stay ahead of potential exploits that are currently unknown rather than mainly reacting to threats as they happen?
I would say we're definitely more on the proactive side, right? Because it's kind of hard to, I would put it this way, like to write a firewall rule for infinity, right? Because you don't know what something is going to be ahead of time, and then try and write some kind of signature to catch it, right? So the one thing that we're doing is literally, having a defensible, secure architecture, like I said, from the silicon going up, and then with our active response capability, look at all of the things that are really indicative of a some type of exploit happening on a system. There's a lot of things that happen right once when a computer is being exploited, and there's a lot of telltale kind of things that happen, and those are the types of things that we're monitoring for. So like I would say any system, right? Nothing is 100% foolproof, but I go back to that defense in depth, right? And that's where we're looking at the hardware-based isolation. We're looking at the encryption, making sure that secure boot's enforced, the data is encrypted in all forms. We have a kind of an autonomous system watching for those exploits, and then you put everything that Tim's doing on top with securing the chain, and it's again defense in depth, right? So even if we fail at one layer, we're not going to take down the whole system, right, or compromise anyone else.
Gotcha.
Well said.
All right. Let's see.
It's hard to ask questions on something that's. It's hard to ask questions on something that's so technical. So everyone's probably deer in the headlights right about now.
I've got some. Okay, I'm not sure if this is for Tim and Brad or both of you together, but it says, why will this technology make VITREUS more attractive to the energy sector customers?
Great question. So I'll take my first 30 seconds, Brad, then I'll pass it over to you.
Sure.
So the energy sector is getting ready to go through a major transformation. A lot of the analog and pneumatic technologies in the grid and whatnot are going to be updated so that they can be digitized, which means that they can be reached, theoretically from, a computer, right? Where that isn't the case now. So what we are able to provide them is compliance assurance and, compliance efficiencies in our systems, right? With ComplyQ and VITREUS Essentials on a very basic, product offering. And this is not just a big need. Is the cybersecurity experts are in very high demand. Their time is in high demand, and there's a lot of low entry things like password rollovers and whatnot that can be automated by our systems. Now, passing it over to Brad on MainSail, if we are housing that data, right, and Brad can secure our system from a zero trust and then add that into other systems, and Brad, I'll let you take it from there. What advantages does that also give to energy?
So you hit on the talent, cybersecurity talent. It is, it's a very high paying profession to get into, and this and that. And that being said, it is very hard to find people that have good skill sets that are able to find or protect assets. And if you can't find these people, and they're like what Tim was saying, like the patching cycles might sometimes people can't do their patchings. They just don't have people that are able to do it, right? The skill sets might not be there, or just the workforce. So one of the things that we're bringing is I want to say it's kind of like cybersecurity for dummies, right? If we're bringing this whole complete package to you that basically can encompass a lot of those security checkboxes that you would have to pay someone to kind of manually do, and if you can just get it as a service, essentially, to me it's one of those things that can help augment kind of the lacking of the cybersecurity workforce.
Yeah, well said.
Yeah, I know if anybody is pays attention to mainstream media. I try to avoid it, but there's a lot of discussions on the news about securing the grid and energy data and all that stuff. So it'd be interesting how that works out for Vitreous.
We're ahead of the
It'll
curve
work
for
out
some
well,
reason.
Sharon.
we're gonna nail it.
Absolutely.
Let's see. Okay, this one, it says, if our node is compromised, would we get a notification, and would there be anything that they would need to do, or would that be handled on the back end?
So we would get notified, and as we just high level described, what the Vanguardian OS and the back end Red Hat, technologies and working with, Brad on the enterprise side, that is something that we would take care of on our side. That's a very important aspect of being able to look at the infrastructure and add updates and just make sure that we continue to enrich not only the experience but the features and the security. The goal long term would be to evaluate what that custodial aspect of the chain looks like long term, but for now that would come back to us.
So all they would need is working internet, so that way they're plugged in.
Yeah, and that's one of our advantages in our intellectual property, right? With our provisional patent, is we want this experience of being a validator on a blockchain to not be a technical nightmare. We want it to be secure. We want it to be about the app. We want it to be about the experience. We want to democratize this and make this easy for a consumer that doesn't have to go out and read about all these firewall ports that they have to open up. And, just we're really looking to just deconstruct all of that. Just come into the VITREUS ecosystem, use the app, get your rewards, stake, be a part of the community, be a part of something revolutionary. Leave all of that stuff to us nerds so we can, make your life a little easier, right, Brad and Drew?
We got you.
Hey, I'm a nerd too. All right, let's see.
You're always an honorary nerd, Jaron. Come on.
Absolutely. We have t-shirts and everything.
Yeah,
I'm just
absolutely.
a Taylor Swift nerd, not
Yeah, we're a Swiftie. That's fair.
Taylor.
I think most people are at this point.
Chad's going to be like, why are you bringing that up now? Last question I see is, will MainSail be a legacy partner who will be overseeing our infrastructure for years to come?
Yes.
Yeah, we actually get that question a lot from the DoD, right? When we're talking about a new technology to have them build on, you're talking systems that have lifespans of 5 to 10 years, and if we start looking, my co-founder is actually from the Navy. You would not believe how long of a life cycle they have when they go on a ship. So the question we get from government is, what's a small startup like you guys? How long are you going to be around? And those kinds of questions. And we've been able to successfully work with the government and satisfy a lot of their requirements. And in fact, there's other things we've done with things like code escrow and those kinds of things that'll be ensure that longevity that will be around, right, and there to support.
We'll have the same questions from your traditional financial institutions, energy, critical infrastructure. Those systems are 5, 7, 10. And some of them their core systems are operating off of mainframes that their logic might be 40 to 50 years old.
Yeah.
And, as we said earlier, we don't want them to have to change that. It's more, getting these technologies in for immediate use and being there for that life cycle is very important to us.
Awesome. Well, let me do one last. I don't see any in here, but let me check Discord really fast, really quick. Okay. I don't see any other questions, so we can go around the horn and wrap up. I'll go last.
Okay. Drew, you want to go first?
I don't really have anything to add other than my brain is just trying to soak in all of this information. I've never used or heard of a hypervisor, much less a type 0. So it's all new to me, but I understand what you're doing and how it works. And it's pretty impressive. When you were talking about being injected before the BIOS, my brain's like, no, BIOS is first. That's the only thing. Like you power on self-test. So the fact that you're at the silicon level, I've never heard of anybody doing that before. And
So we call it the 12 stages of Metal Visor.
okay. Yeah.
I'm at stage 6.
Yeah. And what I like about that scenario is you're doing things that nobody has ever heard of. VITREUS is doing things that nobody has ever heard of. So this partnership and this marriage that we have is just like, I'm excited. I just want to get up and run around. It's incredible. I don't have anything to add.
So Drew, so you work in enterprise support, right? You're part of the escalations. You get the worst of the worst.
Yeah, I get the government, I get Amazon, I get everybody.
You get all that. So could you imagine you're in a meeting and people are like, hey, we're going to install X technology stack with VITREUS and MainSail. How happy does that make you in your daily operations where all you're getting is escalating problems anyway, right?
If I hear that my company is using VITREUS for the solution, that's the day I write my 2-week notice because I'm going to go work for VITREUS. Bye. Good luck. You're in good hands. You don't need me anymore. I'm going to go over here and play. Yeah.
You heard it from a support specialist, folks. This stuff is going to revolutionize. Brad, how about you, bud? How about your closing remarks?
Thanks for having me on today. Honestly, it's fun to talk about our technology. And like you said, there's a lot of wow, I didn't know you could actually do that. Or, I had no idea about this whole security aspect of certain things. What I'd like to, do is if anytime you're going to have me come back on and take a deeper dive on anything, that's fine. But also, the website is there and we have a lot of blog articles going to kind of help and talk through the technology. But yeah, we have a lot that we're doing in, on, not only the federal side, but also commercial and really looking forward to, working more with you guys on architecture and getting this out there.
Yeah. We're honored to have you. It's always fun having subject matter guests on. I'm very fortunate that I've been able to work with phenomenal companies and folks. I would like to propose for the next time we have you guys on, we do it in tandem with our friends at Western Digital, because I think we'll have a pretty fun story to tell everybody as we get closer to testing everything together. So,
are you sorry, Brad. Where are you physically located?
I'm in Northern Virginia, Alexander.
Okay. So I was thinking, if he's close to Colorado, we might as well just all go to Colorado and have a face-to-face.
Go to Colorado.
I think that's in the works. We just got to get Taylor and Yost to get their passports ready so we can get out there.
I got a big suitcase. We'll just put them in there. Fine. It's no big deal.
I'll go for Taylor. I'd be a great step in.
You know what?
Shave your head.
I'm gonna. Yeah, absolutely. I think I'm gonna hold you to that one, Jaron. Jaron, I'll pass to you for final thoughts.
All right. So, wrapping up, I want to thank Brad for taking the time to come and hang out with our community day today. We really appreciate that. And we are definitely going to invite you back. You'll probably get sick of us at one point because we're going to be like, hey, you want to come back and hang out with us some more? After this, we are going immediately over to Discord for the after party. And that is where myself and Drew and Tim will sit down and kind of break this video down into more simplified terms. So if that's something that you're interested in, come hang out with us in Discord. We'll chat over there for 30 minutes to an hour, and it'll be real fun and lighthearted. Other closing notes would be Saturday the 12th at 10 a.m. Eastern kicks off stage 5 of the VITREUS progressive presale. So if you have not bought tokens, bought into the presale, or you already have and you want more, there's your next chance is Saturday at 10 a.m. And if you are interested in our VAM program, the VITREUS Affiliate Marketing, which is essentially you have a link, and if you invite your friends to purchase into the presale and you hit a certain level, then you would get 10% back. So, if that's something that you're interested in, also come hop in the Discord and we'll talk to you about it. So,
another great program.
Yes, it's a great program. It's ran by our Bino, and he is amazing. So,
yeah, well done, Bino.
So that's it for today. Thank you guys for coming, and we will talk to you soon.
Thank you, Brad.
You guys
Bye, guys.
And we're done.